say we have different types of mapping functions, right? We have what we call the onto function, which is called the surjective, right? We also have what? The injective, which is what? The one-to-one. So we have what we call one-to-one mapping function. Is it not so? Where the one I taught mapping function? When in class? Wow. When it's a mapping function, mapping function is like is a way of assigning or linking two or more sets together. Are you there? If we have, for example, listen. If we have, for example, if this is set A and this is what? Set B. Are you there? If the element of set A, if we have 1, 2, 3, and 4, then that of set B we have A, B, C, and what? And D. And I want to map, I want to link A and B together. I can connect 1 to A and B, connect what? 2 to B, connect 3 to what? C, connect what? 4 to what? To D. Are you there? We call it mapping function. And it's called one-to-one what? Mapping function. In fact, it's even bijective. Are you there? It's bijective. We have one-to-one. One-to-one means injective, Abi? Injective. What is injective function? Injective is when every element of the domain has a unique element in the code domain. We call this domain. This particular one is called domain. This is called the domain. This is called what? The code domain. There is always an assignment that links the domain with what? The code domain. The assignment is that 1 is mapped or is being linked to what? To A. Are you there? 2 is what? Linked to B. 3 is what? Linked to C. 4 is what? Linked to what? To D. So this is called one-to-one. When you hear the word one-to-one, it also means what? Injective. That means every element of the domain has a unique element in the code domain. Unique. Meaning 1 is only mapped to what? A. 2 only mapped to what? B. Do you get the concept? Now, if I have this kind of mapping, listen. If here is A, and here is A, and here is what? B. 1, 2, 3, 4. Let's say we have A, B, C, and D. If 1 is mapped to what? This. Let's say 2 is mapped to what again? A, the same 2. Then let's say C is mapped to B. Then 4 is mapped to what? To D. Okay, let me say, if I'm to map this, it will no longer be a function. Let me remove this. Let's say we have A, B, and what? And C. Are you following? So what do you notice here? Every element in the domain don't have a unique element because 1 and 2 are both linked to what? To A. But every element in the code domain are assigned to at least what? 1 element in the what? In the domain. Are you following? Like A is assigned to what? 2 elements. 1 and 2. At least 1 means either 1 or 2 or 3. You get the concept? So since the domain don't have a unique element, so it's called what? One-to-one. It's called onto function. It's called what? Onto function. Onto also means what? Surjective. It means surjective. Surjective function. Now, another way to identify an onto function is that your range will be equal to what? Your code domain. Is it not? Is it not? What's the range? Range talks about the image of A. The image of A are what? A, B, and what? C. Image simply means what are the elements in A? So in what? In B rather. That are assigned to what? To elements in what? In A. Are you following? So this simply means that the image of B, the image of A is simply what? A, B, and what? C. That same image is same as what? Your entire what? Code domain. If I have, let's say I have here to be C. Let me say here is D. What will be the image? You see A, B, and C. Because D is not mapped to any element. But the code domain is what? A, B, D, C. In this case now, in this diagram, the code domain is not equal to what? To the image. When you hear the word image is same as the word range. Whenever the image or the range is equal to the code domain, like we say, that means what? A surjective or onto. But in this kind of diagram, What's our image or range? Is A, B, C, Abi? Are you following? What's the codomain? Is A, B, D, C. Are they equal? No. That means that this is not surjective. It's not onto. So if it's not surjective, it's not onto, what will it be? It's many to what? To one. We have one to one, we have onto, we have many to one function. Many to one function is when we have many functions assigned to what? A particular what? Function. Are you there? And also whereby one particular element in the codomain are not linked to what? Any element in where? In the domain. Because if D is linked to any element here, it becomes what? It's subjective. Do you get what I'm saying now? For the word subjective, the entire codomain must be equal to what? The range. Okay, let's watch. Look at this now. Look at this. What is the gist behind one-to-one? Is that every element here must have a unique element. Is it not so? Now, the last said, if f of s equals to what? S squared. Is f of x one-to-one? Let's verify if it's one-to-one. Solution to this is that we are given what? We are given f of s, right? To be equal to what? S squared. Are you following? It is not one-to-one. Looking at this alone, it's not what? One-to-one. Do you know why it's not one-to-one? Look at me why. And the positive value, you still get to the same value. Like for example, now let's assume the values are of what? Of x. So the x equals to, let's say, -2, -1, 0, 1, and what? And 2. Are you following? Once we are talking about mapping function, listen please. The value, your domain represents your what? Your x. This represents your what? Your y. This is also called what? Your inputs, Abi. These are what? Your outputs. This is also called your independent, right? Independent what? Variable, right? This is called what? Dependent what? Variable. Do you get the concept? So, if we are given this f of s equals to what? S, that means y equals to what? S squared. So I'm assuming what? A range of value for s. So if I'm assuming this, let's look at this. And we are given f of s, right? So let's find f of what first? What's the first s we have here? -2, which is what? -2, I mean all what? All squared. F of s equals to s squared, meaning I'm putting the value of s as what? -2. And what do we have here? We have 4. Let's try what? F of what? -1. What do you have? -1 all squared is what? 1. Let's try f of what? 0. What do we have? 0. Let's try f of 1. What do we have? 1. Abi? Which is 1 square, right? Which is same as what? 1. Let's try f of what? 2. What do we have? 2 squared, which is what? 4. What do you notice? Why is it not one-to-one? The one-to-one says that every element in the domain has a unique element in the codomain. What is our domain here? This, Abi? Are you there? If you check this now, -2 and 2, the value is what? Is 4. So if I'm to draw my diagram, -2 and 2 will be assigned to what? To 4. That means -2 and 2 don't have a unique what? Element. Even -1 and what? And 1. What's the value? 1, 1. I can represent this in a diagram. Let me show the diagram. I hope you are following. I think a lecturer asked this question, gave an assignment, and one of them brought this. This is the question that the lecturer gave. Now, please, watch. So let's create our diagram, our map. Yeah, let's call here what? A, right? And here's what? Here's what? B. A is mapped to B by what function? What's the function of f of x? S squared, right? What is the assumed value of A, of x? The first is what? -2, -1, 0, 1, and what? 2. What is the value of y? Look at this now. From 0, 1, and 4. B. What's the least here? 1. What's the highest here? What's the least here? 0. Sorry. What's the highest? 4. Now, if I'm to bring down my value of y, I won't just write 0, 1, 1, 4. No. It simply means that since the value of x started from what? minus 2, abi, and ends where? At 2. It means from minus 2 to what? To 2. I will also arrange my y in that same manner. Meaning I will start from 0, followed by what? 1, followed by what? 2, followed by what? 3, followed by what? 4. I will stop at 4. It means I will bring out all the range of value from 0 to what? To 4. Is it making sense? So what do you have here? Let's go. 0, 1, 2, 3, and what? 4. Minus 2 is mapped to what? 4, right? Say it this way. What of minus 1? 1. What of 0? What of 1? What of 2? 4. Are you saying it now? So this is not what? 1 to 1. Because, you can tell me. Yes, you can even tell them that because f of what? Minus 1. Is equals to what? F of what? 1. Which is equals to what? 1. Or f of what? Minus 2 is equals to what? F of 2 equals to what? 4. Therefore, some elements in the what? In the domain don't have what? A unique element in what? The codomain. That is just the reason. Is it making sense? Huh? Yeah, it's many to 1. This is many to 1. This is not onto function. Hope you are aware. It's many to 1. Many to 1. Okay, why is it not onto first? Because the image is not equal to the what? The codomain. You get the concept? 0, 1, and 4 are the images, Abi. What is the codomain? 0, 1, 2, 3, 4. So since they are not the same, that means not onto, but it's called many to what? To 1. Many to 1 means I have minus 2 and 2 assigned to a particular number. Minus 1 and 1 assigned to what? A particular number. Do you get the concept? So many to 1. Are you following?